Hi, let's have a look at this question. The question is 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Now we have to calculate the amount of water produced in the reaction. Very interesting question, and what we have to do first of all is to write down the balanced chemical equation. Let us do this. So what is happening here is H2 is reacting with O2 and is forming H2O, that is water. And let's now balance it, and you can see now this equation is balanced. So the next thing is, we know that the amount of H2 that we have is 10 grams and the amount of O2 that we have is 64 grams. So now the task is to first find out the limiting reagent. Let's do this. Now let's convert these weights into moles. First of all, we know that moles can be calculated from weight by using the equation moles is equals to given weight upon molar weight. So using this equation, let us convert this weight of H2 and O2 into their moles. So you can see the moles for H2 becomes 10 upon 2, because we know that molar weight of H2 is 2 grams per mole, and this gives us 5 moles for H2, and the moles for O2 will be 64 upon 32, because we know that the molar weight for O2 is 32 grams per mole, and this gives us 2 moles. Now, as per the balanced equation, you can see that for 1 mole of O2, we need 2 moles of H2 for complete reaction. That means for 2 moles of O2, we will be needing 4 moles of H2 for complete reaction, whereas we have 5 moles of H2. That means H2 is present in excess. So we can say that this O2 will act as the limiting reagent. And we know that limiting reagent is the one that decides the amount of the product formed, which means it is O2 that will decide the amount of H2O formed. And you can see here we have 2 moles of O2, and from 1 mole of O2, 2 moles of water are formed. That means from 2 moles of O2, the moles of water that will be formed are, let's see this, from 2 moles of O2, the moles of water formed will be 2 upon 1 into 2 moles of water, and this means we will get 4 moles of water. And this is what basically we have to find out, the amount of water produced. And you can see the options are in terms of moles, and clearly you can see that it is 4 moles of water that will get produced in this process. So the answer to the question is option D. Hi, let's have a look at this question. The question is, the element with atomic number 98 belongs to which period? Very basic question. Let us see how to answer. So let me tell you, first of all, period of an element can be you can say period of an element can be found by writing its electronic configuration, and according to that electronic configuration, the principal quantum number of the valence shell tells you about the period to which the element belongs. So basically period is the value of, or period is equal to the value of principal quantum number, that is n, for valence shell. Or you can also say that the highest value of principal quantum number according to the electronic configuration of that element will tell you about the period of that element. So this is how we have to find out the period. So let's first write down the electronic configuration for this element. Let's say this element has a symbol X and the atomic number is 98. So that means it contains 98 electrons. So the electronic configuration will be radon 86, then it is 5F10 and 7S2. So this is the electronic configuration. Now clearly you can see that the value of n for the valence shell, you can see valence shell here is 7th shell, and the value of principal quantum number for this valence shell is 7. You can see here n is 7. Therefore this element belongs to 7th period, and hence the answer to the question is option C. Hi, let's have a look at this question. The question is, which of the following orbitals have the maximum number of radial nodes? Very interesting question. So let me first tell you, nodes are basically those regions where the probability of finding electron is 0, that is psi square is 0. And radial node means the region should come along the radius, and it is spherical region basically. and that is how the radial node is also called as spherical node. And let me tell you, in order to calculate spherical node or radial node, you have to use this formula, that is number of radial nodes is equals to n minus l minus 1, wherein n is the principal quantum number, l is the azimuthal quantum number. So now let's use this formula to find out the number of radial nodes in the orbitals given in the option. So you can see in case of 4s, the n here is 4, and for s orbital the value of l is equals to 0. So clearly you can see that here the number of radial nodes which I am representing as Rn will be equals to 4 minus 0 minus 1, that is 3 radial nodes. Moving to the next one, we have 4p. So here you can see n is 4 and the value of L for p subshell or p orbital is 1. Therefore the number of radial node will be 4 minus 1, that is 2. Now moving to the third option, that is option C, where we have 3D orbital, or you can say 3D subshell. So for this in fact orbital you should say, because in the question itself it is mentioned that these are orbitals. So for 3D orbital you can see n here is 3 and value of L for D subshell or D orbital is 2. Therefore the number of radial nodes will be 3 minus 2 minus 1, that is 0. Moving to the last option, that is 4D orbital. So here n is 4 and L here for D orbital is 2. Therefore number of radial nodes will be 4 minus 2 minus 1, that is 1. So clearly you can see that the maximum number of radial nodes are present in 4s orbital. That is the option which is the answer to the question is option A. Hi, let's have a look at this question. The question is, which of the following isoelectronic ions have lowest ionization energy? Very interesting question. Let me tell you how to answer. So first of all, you should understand the factors on which ionization energy depends. So let me tell you, ionization energy is directly proportional to the effective nuclear charge. That is, more is the effective nuclear charge, more will be the ionization energy. Now you can see in this case, the 4 species given to us are isoelectronic, which means they have same number of electrons. So let me tell you, in case of isoelectronic species, the effective nuclear charge increases with increase in the magnitude of positive charge. So let me write it as effective nuclear charge is directly proportional to the magnitude of positive charge, and it is inversely proportional to the magnitude of negative charge. That is, as the negative charge increases, the effective nuclear charge decreases. So it is inversely proportional to the magnitude of negative charge. So we can simply say that more is the negative charge on a species, lesser will be the effective nuclear charge, thereby the ionization energy will be less. So you can see in this case, the maximum negative charge is present on O2 negative, and therefore the answer to the question is option D. Hi, let's have a look at this question. The question is, which bond angle theta would result in the maximum dipole moment for a triatomic molecule XY2? Very interesting question. So let me first tell you the formula to find out the net dipole moment, which is very, very interesting. You can see dipole moment is a vector quantity, and whenever you have to find out the vector resultant, or you can say resultant for dipole moment, then you have to use this formula, that is mu net or mu resultant is equals to, this mu resultant is equals to mu1 square plus mu2 square, wherein this nu indicates the magnitude of dipole moment, plus 2 mu1 mu2 cos theta. Now you can see in case of XY2, the bonds that are present is between X and Y only. That is, there is only one type of bond, and that is XY bond, which means both mu1 and mu2 same in this case. Why? Because both the dipole moments are between X and Y. So obviously this dipole moment that is between the first XY bond and the second will be same. So this tells us that the entire value now depends on the value of cos theta. So now you can see it is cos theta that will decide whether the dipole moment will be maximum or minimum. Now, if you see the options, in option A, we have theta equals to 90 degree, which means the value of cos theta will be 0, and hence the resultant dipole moment will become mu1 square plus mu2 square and under root of it. And in option B, you can see the value is 120, in option C it is 150, and in option D it is 180. Now you can see all these three values are present in the second quadrant, which means the cos theta for these values will come out to be negative, and this leads to decrease in the resultant dipole moment, and hence the maximum dipole moment for this triatomic molecule will be at an angle of 90 degrees. So option A is the answer.